Good afternoon. My name is Peter Woraznik. In this video I'd like to present a brief description and demonstration of the main functions of an invention of mine, the Mechanically Self-Regulated Propeller, US patent number 9616991B2. Behind me you'll find the third propeller prototype. This is the first full-scale example, with an overall diameter of 7 feet when in operation, and when non-powered and closed, a diameter just above 11 inches. It's constructed almost entirely out of aluminum, giving it a 90-pound overall weight, and at the moment has 6 blades installed, each with a length of 3 feet and pitch of 30 degrees, although when you consider the modular nature of the design, this particular example can function in 2 or 3 bladed configurations as well. For the remainder of this demonstration, I ask that you please imagine that the propeller is currently attached to some form of aircraft. Currently, the propeller is in its non-powered and closed position, the idea being that when it's not in operation, it removes as much of its assembly from the airstream as is possible. When power is applied, an initial centrifugal force, followed by thrust generated by the blades themselves, will cause each blade to rotate outwardly 90 degrees into the propeller's open position, where they will remain for so long as power is applied, and the forces generated by the propeller are capable of overcoming the forces acting upon it. Once power is removed, the propeller will automatically begin to return to its closed position. If the aircraft is at altitude when this occurs, this immediately allows it to function as a glider, so you can take advantage of things like thermal updrafts or wind direction and speed to operate more efficiently. When the propeller is once again required, the operator simply applies power, and the open and closed functions of the propeller can be used again repeatedly for as long as is necessary. To prevent potential interference between the propeller blades, or potential damage to the aircraft or the propeller itself, during both opening and closing operations, the propeller changes position in a controlled, safe, mechanically regulated fashion, requiring no outside interference from the operator, aside from the decision to enable or disable power to the drive motor. This doesn't mean, however, that the operator has no direct control over the current positional state of the propeller. Due to its unique design, should it be required, the operator can choose to force the propeller to change position manually, without applying rotational power. Once a forced positional state is no longer required, the operator simply relinquishes control, and the propeller once again becomes self-regulating. If the aircraft is at altitude when the operator chooses to force the propeller into the open position while non-powered, the propeller will immediately begin to generate drag due to the force of oncoming air. In this fashion, the propeller can operate as quite an effective air brake. Furthermore, should a pair of these propellers be installed, one on each side of the craft, this air brake function can be deployed selectively to generate drag on only one side of the craft at a time, and thus alter its course as well. This brings me to a major function of the propeller which may not be immediately apparent upon first examination. As you can see, the prototype is currently driven by an electric motor, and in any real-world implementation, this would be the expected source of drive power as well. When the operator chooses to employ the air brake function of the propeller, and the propeller is forced into the open position while non-powered, it can additionally be expected that the force of oncoming air will cause the propeller to rotate in what's commonly known as windmilling. This windmilling action can be used in conjunction with the drive motor to generate electricity, which can then be stored in an onboard battery bank. In this fashion, the propeller is additionally capable of operating as what I believe is one of the first practical regenerative air brakes, allowing it to drastically improve the range of an aircraft by using any reduction of its speed or any alteration of its course as a source of regenerative power. When all the functions of the propeller as demonstrated in this video are combined, and with proper materials and engineering, I believe this propeller has the potential to operate as the core component in one of the most efficient aircraft propulsion systems currently possible.